Revit is a building information modeler, or BIM, and the thing which puts the I in BIM is the information, and that is defined in Revit as parameters. And parameters are basically different properties of the elements within Revit, say the thickness of a wall or the material on a desktop. Before we go creating our own custom parameters, let's take a look at one of the objects in our model, this desk, and see what kind of parameters it has. Now, like a lot of components that are standalone components, to edit it, you just double-click on it, and it magically opens up in a new file. And you can see here, it's a 3D model made up of masses, right? So these are familiar items. And each of these masses can be modified in different ways. And this has a number of parameters. The simplest parameter is a material parameter. And I'm going to shade this view so that we can see what kinds of materials on here. You can immediately sense that something is going on. This is a different material. It's brown. The way that is defined is in the mass itself. If you go down and you look at the properties of the mass, instead of being able to pick on the material, see how I can't click on here? If you can't see it, I'm clicking away. Instead, it has this little equal button, which is, if you look at the tooltip, it says Associate Family Parameter. If I click on that, you'll see that there are family parameters here. The top material, there's also leg material and body material. And it should be pretty clear which material each of these is meant for. And you might say, well, why don't we just paint on these surfaces? There's a couple of reasons, but the main one is once this model is created, we want to be able to edit the materials in our main project. And having these parameters makes that much easier. Now, absolutely, the materials that are assigned to these are here in the main, in the component that we created. So you see how it says cherry. That is created over here in our materials library, just like we would in the main project. The only difference is that the materials here, there are a lot fewer in the model. And I can see those by just going to the flyout menu here and just show me the ones that are in use. And oh, actually there's a lot in use, kind of surprising. But here's that cherry material. Now, one warning is that the name of this material will translate back into your main project. However, sometimes the definition is lost, especially if you're not using the materials from the main materials library here, the appearance library. If you're using one of these assets that are fairly typical, it's usually okay. It will make it into the main project. Sometimes these images are lost, especially if you've made a bunch of updates and you send this back to your main project. That said, if I were to paint individual surfaces in here, different materials that I've created in this project, those materials will load into my main project, and then I can modify them in the main project as I see fit. Other parameters are dimensional parameters. And I'm going to go and I'm going to open up the floor plan here of my component. And what you'll see are a series of different types of lines. The dashed lines are reference planes. You might say, wait, reference planes, I've heard of those. If you go on the Create tab, you'll see you can create reference lines and reference planes. And each of them has a different purpose, but reference planes are three-dimensional planes that allow you to lock dimensions and objects to them. And they're really handy. For example, if we wanted to define the width of this desk, I can create a mass and lock either end of that mass to the width. I can also lock the other dimension to the depth. And those become parameters when I define them as such. So in this case, you see how it says depth equals 2 feet - 6 inches. That is a parameter that I created, or the people who created the desk created, the creators of the creation. And they did it by just clicking on the parameter box, and it allows you to create new parameters. And these parameters can be either type or instance. Instance parameters, let's say you have 3 different desks and you want 3 different countertop materials on those desks, you would make the parameter instance, and then in your main model you would be able to make each one separate. A type parameter will change them all, like your typical component or block in other programs. Finally, parameters can also be assigned in vertical views. This is the front view of our desk. You can see here there's a reference plane, that's the ground floor, and this object is placed on the ground, so that is your main reference plane that's kind of external to the object. And you may have noticed that when you import components, often they only want to go on walls or floors or ceilings. But the other thing is you can reference vertical elements as well and lock these objects to those vertical planes. See here, this is the work plane reference lock, and this object is locked to that vertical height. Again, when you go into your main project, you can change that height. Now, each object has family types, and what that means is overall this is the desk family. And in fact, if I go here to the family category, I can choose which category that desk shows up in. So typically that would be furniture, but obviously there's many other things, doors and whatnot. You can actually change it here in that menu. You can also change a few other parameters if it is work plane based, or if it's always vertical. Now in this case it's always vertical, but it's not locked to a work plane, which means I could, in theory, move it up off the ground if I had some reason to do that. There's some other elements in here that are not quite as critical for a desk, including defining the edge of a room, which you don't typically do, but sometimes you do. So that's the family type, or the family category. The family types are, and we've seen these before when we've loaded it in, when you can choose different versions of this desk. And what happens when I change these, see how the dimension the name has changed to 72 inches. When you do that, you can come in here and you can actually change the parametric dimensions. So in this option, the width of this desk is 6 feet long, or 72 inches in the case of the name. If I choose this other family type, 60 by 30, you see how the width has changed. And what they did is they created a new family type, and you can make any type you want, so I could make it 100 inches by 36 or something like that. The name has nothing to do with the parameters, it's just the name. And in my new one, I could change the width to be 100 inches. Now, of course, that would be an awfully big desk. But when you hit apply, you should see that the desk got a lot bigger. Now, it's kind of ridiculous to do that, but it shows how the parameter, which is associated with these two outer dimensions, just by changing the number, it changes the geometry. And that's the beauty of parameters. Okay, so let's go create our own. So let's make ourselves a nice ottoman, and that'll be a good way to show how to apply materials. And in theory, I could just go and do a component in place or even a mass in place. However, parameters generally work best on standalone components. So let's make ourselves a new family. Go to File, New, Family, and you want to choose the Imperial menu here because we aren't metric, and choose something that makes sense. These family definitions are important because it determines a lot of the reference planes and other parameters that are kind of built in to the type. Click Open, and let's create ourselves a little extrusion for the base of the ottoman. Make it nice and big here. There we go. And I think what I'll do, go here to the 3D view. I think I'll give myself a base, and I'll make a second part of this for the top of my component. And of course there are so many ways to do this, but let's see, I think I'll just go to the front view and I'll copy and paste in this same mass. So now I have two of them, and I can just stretch the mass up for the top of the ottoman. Again, your modeling technique, I could have probably done this as a revolve as well. So to associate a parameter with one or another pieces, and maybe I want independent control of these two pieces, that's why I made them as two pieces, You select the mass that you created here, and you can see I'm still in the create menu here, inside the component. So I haven't loaded it into my project. I'm still in my independent family. And when you select a mass, any shape that you've created, the properties here on the left will show all the properties of that material, of course. And one is the actual material. Now, I could just click here where it says material and pick one out of my library. Now, of course, that is not nearly as good as using a parameter, because in order to change that material, I'd have to go and edit the family. And remember, I'm planning to load this into my main project. I don't want to have to open up the family every time I want to change material. So what you can do is associate a parameter. There's a little teeny tiny box right next to the material that when you click on it brings up a new menu, the Associate Family Parameter menu. And it's quite simple. I can just click on the little Create New Parameter button and say this is my base material. And it knows that the type of parameter is a material because I clicked through the menu. Now, there are two options, type and instance. The type parameter will change all instances of this. So let's say I have 4 ottomans sitting in my project. If I make this base material a type parameter, all bases will change in the main model. So I'm going to try that with I'm going to assign the base material to the base mass. I'm not going to come over here on the top material, and I'll do the same thing. I'm going to make a top material parameter, again, calling it something that makes sense. And I'm usually pretty lazy about naming things, but you do want to name these in something that's understandable. Now, in this case, I think I'm going to have the base be all the same, but maybe the top material different in my main model. So I'm going to make that an instance parameter. And partly this is to show you what will happen. So I'll click OK, and OK one more time. And I'm not actually going to assign any materials here in this model just yet. What I'm going to do, I'm going to save my component somewhere onto my project, and we'll just call it Ottoman, because that's a clever name for it, don't you think? And then I'll just load it into my project. And here we go. I'll place it in a view, which I can see here. Let's see, I think this is the front view. Oh, no, that's the wrong one. Let's go to this exploded view. There we go. And here's my model. Now you might say, well, that really doesn't look very good, does it? There's not a lot of materials. Let's make a couple of copies. I'll just control drag to copy over the object. And you'll see how these parameters work. First of all, if you select the object, only one parameter is visible here in the menu. So I could click here, and this is the instance parameter. So each of these can be painted uniquely. I just click on the material and go, it'll bring up my menu, and I can change one to have 2 different fabrics here. And you can actually select more than one object. As long as they're the same object, that same instance material will show up, and you'll be able to paint them. You might say, well, okay, that's great, but what about the base? This is where the type parameter comes in. This family type, I have to edit the family type, and now in that menu, I'll see the material, and I can pick it out of my library. And of course, you do have to have library materials created in order for this to work. Now, what if I want to, say, create a profile? This is a pretty pointy-edged ottoman. If I wanted to create a profile around the edge, can I paint that, say, a highlight color, a different color? Well, let's take a look at our model. I'm going to close the extra windows, by the way. They're getting kind of annoying. It makes it a little easier to find what I'm doing. And except now I want to open up this one because I like this one better. So let's create the profile, and to do that you create a void form, and I'm going to try and soften the edges of this thing to show you how it works. Now, because of the way I created this, which is to say I used void extrusion to create the kind of rounded form, it's not a separate object, so I can't select it individually. I have to use the paint feature, and you can do that by typing PT for paint. And by the way, you can remove paint also. It's underneath that menu. But when I click the paint tool, I'll choose the color that I created here inside the family. And it's perfectly fine to create materials inside the family. You see how, because I've made this realistic, you can see that the top of this is now kind of a funny, not very pleasant yellow color, but it sure shows up well on your video screen. So when I save this model, I'll just hit Control S and load it into my project, I can overwrite the existing versions and its parameter values. And in theory, what will happen, and of course it wants me to save, it always does. In theory, what will happen is any object that has a parametric material assigned to the object, it will take that material, even if it's an instance parameter, so a parameter which is changed in this main model. However, it will get overridden by this new material that I created. Now, one tricky thing here is this new material was imported with the family that I created. So if I go to Manage, I should see that material, Ottoman fabric. If I change this material here, for example, if I made it some other fabric, that material change will not go backwards into the family. So if I were to change it and I went back to the family, it would remain in the family the same way. So you have to be careful if you have to, for some reason, go back to the family and edit that material. When you re-import it, it will overwrite any changes. So in general, a good rule of thumb is to apply parameters here in the family, but then don't apply the materials until you get to the main model. The only time that you'd want to do it the other way is where you have a very special instance. In this case, I've got a fabric that I want to be unique, but I couldn't break the geometry in an easy way. To demonstrate how to make dimensional parameters, I think I'm going to create a sculpture niche here, something that's inset into a wall that you put a sculpture in. Now, there are going to need to be a few dimensional parameters here. First of all, the height of the bottom of the niche above the ground is one thing I'm going to want to be able to adjust. And then the height of the actual niche itself and the width of the niche itself should also be adjustable. And maybe it would be nice to be able to change the size of the trim. This is in addition to the usual changing of materials. Finally, it might be nice to have a few options for the type of sculpture that's in there. And that's another type of parameter that we can have, a visibility parameter. In this particular one, it's going to sit inside the wall. So when we place this niche, it'd be nice if it cut an opening in the wall. The first step is to, like we did before, create yourself a new family. Go to File, New, Family, and in this case, again, go to the Imperial level here. I'm going to go down to Generic Models. And you'll notice here there's a couple of different flavors of generic model, which is funny because generic doesn't seem like it would have a flavor. Some are floor-based, some are face-based, which means it could go on a floor or a wall or a ceiling. Some are ceiling-based. I'm going to do one that is wall-based. And this will allow me to do a number of things. Open this up. And one is create an opening in the wall. So only certain types of generic face-based models will allow openings. And in this case, because I want to specify a wall, I want to have that available. Now what you'll see here in this family, there are a couple of elements already in here. First of all, there's a wall, and it's just a generic 6-inch wall, and there's actually different sizes in here. I think I might have used a 12-inch one in our project. It doesn't really matter because it will adapt to whatever wall you place the object in. Then you'll see these dashed lines here. These are the reference planes that the geometry can be connected to. And I'm looking at this in plan, but if I come here to the placement side of the placement side elevation, you'll see that there's also reference planes here, and they are created with names. So for us, let's start by creating our own reference plane for the bottom of the niche and also the top. And you go to the Create tab and choose Reference Plane. And you can place the reference plane by just drawing it as if it was a line. However, it's actually a three-dimensional object. And if you see here, it says click to name. I'm going to do that. I'm going to click to name that, and I'm going to call it bottom of niche. There we go. And there's a dimension here, and I can set the dimension. So let's say we want it to just start out at 2 feet. The tricky thing is that the dimension itself is, unlike in the regular model where you can kind of click on it to make it permanent, this doesn't have that option. So if I want to specify a parameter for that bottom of the niche, I actually have to first annotate a dimension. So click on Annotate and then Aligned Dimension, and click on the bottom reference plane first. And you see how it gives me an option for reference level. It knows that that's the typical thing you snap to. And then I'm going to snap it to the reference line that I just created. Move my dimension string off. Now that I've created it, what I want to do is create what's called a label. And up here, when I select the dimension, you'll see an option for label. And it's a parameter type. I can just create a new one, and I'll call it height above floor. I could probably call it bottom of niche or whatever it is that I want. As discussed before, there are instance and type parameters. So I'm going to make this an instance parameter, and that way I can have some niches that are down low and some that are up high. And click OK. And now what you'll see is that my dimension string is appended with, or prepended, I guess, with a note about the parameter that has been assigned to that. And I can do this for the height as well. I'll just make a copy of this parameter here. And you see when you make a copy, it just gives it the number 2, which is not terribly exciting. But I'll call it top of niche. And I'll do the same thing. Create a dimension string, and then apply a parameter. And by the way, all of these drawings are, as is typical of Revit, all orthographic drawings are to scale. And if I click on the spot that says the scale, I can make it a larger scale, which might be handy because the text is getting a little hard to read. And as I add objects, that can be a problem. Now I'll go to also draw in some reference planes for the width of this niche. It's the same process. You can come in, draw it, label it. I'll call this one right side. And I can even use some of my editing tools. I could mirror the left side so that it's on the exactly same side as the right. Again, you see it just numbers it kind of sequentially, so I'll call this left. Now, there's a couple of things. You'll notice there is one reference plane that is part of the family, and it has a pin on it. This pin, first of all, it prevents you from moving it. And second of all, it's kind of a base part of this family. So it's sort of how it's defined. So I'm going to use that as a reference for these two individual reference planes. Again, just come in with the Annotate tool. I'm going to dimension them both off of this center reference plane. But then I'm going to force it to have EQ, equal. And now those two will always be the same distance apart. Finally, I'm going to go and put in another dimension that is going to be for my label. And this label will be the width of the niche. So far, I've drawn a grand total of nothing, but you'll see the reference planes are here, and in fact, if you go to the floor plan, those reference planes are here as well. All right, now let's start trying to draw some objects here, and what I want to do first is cut a hole in this wall. So if I go to the placement side, and again, it's important to note which side you're drawing on. One unique feature of this type of component, a face-based component, is that you can add an opening. And I'm going to click the opening tool, and you'll notice here it gives me the little menu, which is the usual purple line. I'm just going to draw a rectangular opening here. Now, one thing is when I draw the opening, you see how it has these little lock buttons. That will lock it to the reference planes that I pre-drew. So now if I were to say change the width, it should change these reference planes as well. And now I click the checkbox, and like magic, again, you see nothing here. But if you go to the 3D view, you'll see that now I have created a hole in the wall. Now, let's draw some geometry. I'm going to use an extrusion like you typically do to draw the trim around this. Once again, you go to your Create menu, draw extrusion. I'm going to use a rectangle, just like I did with the opening. And just like I did with the opening, I am going to lock that first rectangle. I'm going to lock it to my reference planes. Again, anytime I make a change to these dimensions, this inside face of my extrusion should modify. It should open up just fine. And let's give ourselves a nice 3-inch piece of trim. And I'll just use the offset tool. And you see how it makes a nice trim. And if I click the checkbox, you might say, wow, that's really great. Here, let's look at that in 3D. Oh, it's terrific. Oops, except it's going the wrong way. See how I can drag it to go forward. And it is nice periodically to check and make sure that you're getting what you think you're getting when you draw these shapes. So we can add parametric dimensions to the width of the trim. It actually works pretty much the same way as the other parameters that we've done. You just create an aligned dimension and place it. And I want these all to be the same, so I should have dimensions for all of them. And one of the reasons that we're doing this is you will find that things like windows, doors, things which have lots of trim on them, this is pretty much how they're all put together. They are placed with dimensions that are all kind of locked to the parameter. Let me grab this dimension. I'll make a new trim parameter. However, this one I'm going to leave as a type parameter, and that way all of my niches will have the same kind of trim. I'll click OK, and you see how this one says trim, and I can come in here and I can select these other dimension strings. And by the way, sometimes when you're selecting stuff, it can be a little tricky. You might select other things in the background. Don't forget you can use this filter option, and that will show you everything we've selected. Oh, I guess I only had dimensions selected. That wasn't nearly as hard as I thought it would be. But anyway, I can assign the same label to all of these trims and what the pieces of trim, and that will lock it into when I make a change to the trim dimension, they'll all change. And the other parameter I can add to the trim, if I go to the left elevation, see how here how there's this reference plane that is the wall, and then here's my mass, and the inside face of this. You know, I could have the trim sit way out in front. However, what I want to do is lock the inner part of the trim to this wall face. I can just drag it to the wall face, and up pops my little lock button. I can just lock that in place. And now I can do what I've done in the past, annotate and create another dimensional constraint for the thickness of the trim. And of course, this is awfully thick here, right? This is 1 4 31/32. So that's pretty thick. You see how as because I locked the dimension in place, it should change it. Oops, remove my constraints. I guess I shouldn't have locked it. And it will remain locked to that reference plane on the back side. What I want to be able to do is change this dimension, make that parametric. And again, I'll have to make a new label, trim thickness. And again, I'll make that a type parameter. And now that I have a bunch of parameters all set up, my beautiful beautiful model here. It's time to talk about families. We're going to have the family talk. And, before we have the family talk, it is absolutely possible to add other elements to this. For example, a crown molding. And you can snap and lock the crown molding to the top of this piece of trim so that the crown grows and shrinks as the trim does. And of course, I've just created boring rectangular pieces of trim. You could create all sorts of fun shapes with something like a sweep. This path of the sweep could also be locked to the opening. I think I'll put a piece of trim over this opening here and kind of a crown. And obviously I can do it in more complicated ways, but just creating an extrusion is fine. However, getting the reference planes locked is a little more tricky because I want it to go past the edge of this trim, no matter how wide the trim is. So to do that, I can use what are called reference lines. Reference lines basically work the same way as reference planes. In fact, I could probably use a reference plane as well. I'm going to draw this line is aligned with that edge, but maybe I'll move it out, say 1 inch. And I'm going to mirror it so that there's one on the other side. There we go, we got one on each. And I can stretch my mass that I created so that it hits that line and is locked to it. And same with this side. I can lock it right there. I can also stretch my mass down and lock it to the top of the trim. So in theory, no matter what the size of the trim is, I can have my crown be the right height. Finally, I can put a dimensional parameter on the top of this mass and define the thickness of the crown on it. And you don't want to forget to lock the back side here. I want to lock it to the face of the wall so it always remains the same. So you can see I've created a number of parameters for the crown, the thickness, and the projection. And by the way, these are actually kind of hard to see because the default visual style is wireframe. You can make it shaded. However, be aware that some objects may cover up other objects in shaded mode, so it's a little hard to see. So for example, I made a little shelf here down at the bottom, but you can see part of it is covered up in shaded mode. That's probably why they use wireframe, but also nice is to just check the 3D view, and it will have the parameters visible in addition to all the geometric elements. And you can see here I've created a little shelf for the bottom. Again, these are just simple slabby shapes. If you'd like to get a lot of extra credit, you can create things with, say, molding profiles, using either an actual profile and a sweep, or using voids to cut the faces. Another type of parameter is what's called a visibility parameter, and that basically determines if something you put in your component is visible or not. Good name, don't you think? And what I'm going to do is put in some sculptures here, and I'm going to have two different families, one with a bigger sculpture and one with a smaller sculpture. And I think I'm going to insert something from SketchUp because there's a big library in SketchUp of objects that you could use. I could also use masses, either conceptual masses or regular masses in place in the main project. However, you cannot put a conceptual mass in here inside this component. So I'll just import CAD. And I have an anvil here that I've created. And if you remember from inserting SketchUp objects, you typically want to position at the center of the model, but manually. That way you can kind of find the object. And typically what Revit will do is it will put it in on the ground. And sometimes you'll get a message saying, we don't like this geometry. But let's take a look at the elevation here. Here's my lovely anvil. And interesting enough, you can use reference planes with these anvils or with any of these objects. Just use the Align tool. Maybe I'll align this with the top of the shelf here. I can align that with the bottom of the anvil. Like magic, it pops up there, and I can even lock it in position. And by the way, I do tend to put these SketchUp objects on the ground. At first, just with SketchUp, you never really are sure where the base is going to be where the bottom is. So sometimes they can show up in outer space, takes a while to find them. So here's that beautiful anvil in elevation. And let me insert the other sculpture in the same way. Now each of these objects here, these two sculptures, I can create what's called a visibility filter here, a visibility parameter. You just click on the little teeny tiny box that is the parameter creator or parameter chooser. And there's, like before, a button for a new parameter, but this is a visibility parameter. And like before, you can make them a type or an instance parameter. I think I'll just leave it as a type parameter. And I'll call this one, which sculpture did I select? The big one. So I'll call this big sculpture. And OK. And OK. And then this smaller sculpture, if I can select it, again, sometimes you have to use tab to select different objects. I'll create one for this parameter. And basically these are toggles on and off. So you could have them both on at the same time, or you could have one on at the same time, or none on at the same time too. So I'll click OK and OK to finish. And now what we can do is create some family types. And basically family types are collections of settings, or a collection of settings that you have created parameters for. And it's over here in the Family Types menu, as we saw with the desk. Click on that one. And this is actually a good way to kind of flex your parameters and make sure that they're all working. And you can see here also I've created some parameters for the crown and shelf material and the frame material. I could, again, easily define those inside this object, or in this case, I think I'll wait and define them in the project because all of my materials are in the project. No sense in modifying that. So first of all, you need to create some family members. So let's make a new family member. Click on the new family member button, and I'll call this Anvil. Oops, Anvil. Okay. And what you can do is you can change any of these parameters, and it will be associated with this type. So whenever you choose the Anvil type, you'll get a certain dimension. So I think I'll leave some of these the same, but maybe I'll make the width 3 feet and the height 3 feet also. Hit apply. And you see how the niche gets a lot smaller. In fact, 3 feet might even be a little too tall for this teeny tiny little anvil. Such a cute little handy dandy desktop anvil. So I'll make my niche a little bit smaller. And I could change some of the other functions. But the other one that I want to change is turn off the big sculpture. And if you hit apply, now sometimes with imported objects, they won't disappear until you actually get them in the model. But you can see that most of my other parameters seem to be working just fine. It shrunk the size of the opening, the width, and the height. Now I'm going to create a new family member, and I'll call this random sculpture because I don't really know what it is. In fact, I think that might have been what it was called in SketchUp. Click OK. And in this one, I'm going to turn off the anvil, but I'm going to turn on the big sculpture. And I think I'll give myself a little bit more width and a little bit more height. 4 feet width, and let's make this 4 feet tall. It's kind of a squarish. Oh, not 4 inches tall. That's pretty small. Let's make that 4 feet tall. Apply. Okay. And the other thing is that when you bring this niche into the model, because it's going to be hosted on the wall, I could change the height above the floor here, but I think I'm actually just going to move it up and down in the model. That's going to be a lot easier. And that'll be kind of the default height anyway. So hit apply and OK, and then I'm going to save this little Pella and load it into the project. And if you've already inserted it once, you want to override what was in there. And now I'm going to go and insert a couple of instances in the wall. So you just go to Place Component. Our lovely niche should be right there. And you can place more than one instance. Of course, it is kind of cutting through the entire outside wall, which is not so great. And, you know, I think I made the width and the height. These may have been made into instance parameters by mistake. Either way, you can change the options in here. This is an example of changing an instance parameter. So again, I can change the height here And the width here, I have ultimate kind of flexibility. And I could make many other options. Oh, I think it was 4 feet. Let's make it 3 feet and kind of flex it and make sure that it works. But you can see that it's pretty easy to create an object with multiple parameters. There are many things that I did not create here. I probably should create some kind of back to this. I could insert lighting components inside this and have those turn on and off as you edit the component. And these are things that you will see as you travel through the world of BIM objects and 3D, or not 3D warehouse, but Revit City. You'll find all sorts of families, and they are created many different ways. So trying sometimes to modify the dimensions. For example, I was able to modify the width and height here as instance parameters because that's kind of the random way I created it. But if I go to edit type, the family parameters, the overall family parameters, are here. So if I say changed the shelf projection to a much higher number, that should change them all. And in fact, it did, or at least it did. I think it changed all instances of this anvil niche. So the option for our uses here, I'd like you to create at least 3 different alternatives. You can create a niche. You could also use these exact same principles to create something simpler, like a bookshelf, or something more complicated with, as I mentioned, niched nested subcomponents. There are other options, of course, when you create these. There are many, many different ways to fiddle with these parametric components. One is I could have, instead of using an opening, which is typical of windows and doors, I could have used a void to cut just part of this wall. Now, the walls weren't very thick in this project, so I thought, oh, I'll just cut all the way through them. But you can tell Revit to cut with voids when the family is loaded. And this will allow you to, say, cut only halfway through the wall. And again, this has different uses than what we're doing here, but certainly would be fine. Another thing that you'll see is special kinds of text and drawings that are just symbolic. They're not actually meant to be part of the model. An example of this might be a filled region. And this is very common where you want to have, maybe you want to cover up these models that are showing here without having to hide them, or you want maybe a spot on the floor to show up. Like for instance, if I draw a filled pattern here, this is called a filled region. You just draw the boundary, and there's a number of different line types that you can use, including, let's use generic models. Cut, I think that's a heavier line weight. Cut, and or maybe not. And this will create a region filled with some pattern. And in fact, if you want to know what the pattern is, you go here and you edit the type of the filled pattern. Right now, let's see, it's a diagonal crosshatch. Let's fill it with a solid color, but let's just make it kind of gray. And the reason I might want to do this is that in floor plan view, for example, it may be that you don't actually see the opening because the niche is mounted too low. It's mounted below the cut height of the floor plan. You can also control the visibility like you do in other views, but with other objects. Except here, there's an option to actually control whether or not it's shown at different scales. So in Revit, you can have a coarse level of detail, a medium level of detail, and a fine level of detail. Typically, these are larger scale drawings where you may be drawing, say, a plan detail. Obviously, we don't need to cover up anything when we're doing those, but perhaps I want to cover these up when I'm just looking at my floor plan. So now when I load it into the project and I'll overwrite the existing version, what you should see, first of all, you don't see anything on the ground. Here, let's look at the exploded view. But when you go to the ground floor plan view, you should see when I go to hidden line view, and I change this to the coarse scale, you should see how suddenly my poché shows up, and now I've hidden these sculptures. And it's kind of a way of removing some extra detail from your model. Finally, I haven't applied any materials yet, but that would be another thing to test. With all of these objects, obviously, as we said before, the type parameters, the family type parameters, are where you add the material, right? We set it up that way. If we had made them instance parameters, it would have shown up here, which in a way kind of saves you one click. But it means you have to select every instance of the parameter. In this case, I'd probably have a lot of variety, so I might have many different instances. But then for painting the sculptures, you do have to go to the Manage tab to Object Styles. Unfortunately, that's just the way. You have to paint SketchUp objects and go to Imported Objects, and what you should see is Imports in Families. And of course, we do have to figure out which one is which, but this is where I hopefully labeled the tags in SketchUp so that they would show up here. I probably didn't. I probably made them all under layer 0, which was not a good idea. I should have had one that said anvil, one tag that said anvil, and one tag that said random sculpture. Then I could paint them. But anyway, I'm pretty sure these are all going to be on layer 0. If I just go in here and I pick here, I'll make them out of fabric because that makes a lot of sense, and hit apply, you should see the objects change color appropriately. That's basically all there is to it. Create 3 different family types, which are distinct. Hopefully they flex properly and you can get the different dimensions to work, and insert them somewhere into your project.